Hello everybody, welcome to lesson number 6, slope and graphing. Let's get right into it. First, you're going to see what we have here is a coordinate pair. It's written in x comma y. Your x will move you left or right. Your y will move you up or down. You're never going to move both left and right, and you're never going to move both up and down, but you could do a combination of these two depending on what they put inside there. You always do your left and right movement first, followed by your up and down. That's why they have it in that alphabetical order like you see here. So I'm going to plot these 4 points on this here plane. Then you're going to plot these ones. You can plot them all on the same one. So if you need to get yourself some graph paper or whatever and set that up, go for it, because I want to make sure that we can plot points without any kind of trouble here. So let's try these out. Point A, we want to move positive 8, so 8 to the right, and then negative 2, y would be down 2. So 8 to the right, and then down 2. I'm not going to count every single time, but I will this time for you, using this fun little hand. Right, 1, 2, 3, 4, 5, 6, 7, 8, and then down 2, we'll put our point right here. And I'm just going to label that A. Okay, problem B, it says negative 5, so we move left. Positive 6 will tell us to move up, so we move 5 left and then 6 up. That is point B. Notice, by the way, every time we started back here, this, by the way, is called the origin. It's where you start, your original starting place. Point C, it says move left and then down, so we move left 2 and then down 3. That's point C. And finally, 3, 5, we move positive 3 and then up 5. So 1, 2, 3, and then up 5. That is point D. So you have 4 points to try on your own. Pause the video and resume when you're ready to check. Okay, let's see. On the same plane, we move negative 8, so 5, 6, 7, 8, and then down 6. 1, 2, 3, 4, 5, 6. That was point E. Point F, it tells us move positive and then down 2. So positive 3 and then down 2 is point F. Point G is positive 7 and then positive 9. So that's 5, 7, 8, 9 for point G. And then finally H, negative 9, so 5, 6, 7, 8, 9, and then up 4. 1, 2, 3, 4. Okay, plotting points. Very easy. We've got to get used to doing that because we're going to start seeing functions coming up, and we're going to be plugging in an x, and it will give out what we call f of x. There it goes. F of x, which is really the same thing as y, right? Whatever you plug in going left and right, your output up and down will be your f of x, your y. So we're going to want to keep track of doing that, because later on in the year when we start like graphing functions with tables or whatever, we want to be able to graph them correctly. Okay, let's move on to slope. Slope is how much something is increasing or decreasing by a constant rate. If you talk about, like, every week you get paid $5 and you put it into a bank and you started with 20, how much will you have, right? You can write a system including slope with that, and you can calculate how much money will be in your little bank, right? That's what slope can do for you. We refer to slope a lot of times as M when we look at a formula, which you'll see on one of the upcoming pages. But for right now, your slope is going to be equal to y2 minus y1, right? Your y is on top, over x2 minus x1. You're going to have two coordinates, which you'll be able to call x1, y1, and x2, y2. They'll give you coordinates, or you'll be able to look at points on a plane and get the coordinates. And you can just label x1, y1. It's that easy. Then you plug in. This equation is really nice because we look at slope as something called rise over run. Rise would be how much up and down you go, which corresponds with your y's. So if you remember rise over run, you'll remember to put your y's on top. So I have a couple example problems that ask us to find the slope of a line with these points. If you need a label, right? x1, y1, x2, y2. Now, if you didn't have that written down, rewind it, write it down. But that formula is pretty easy. It says take y2, which here is 4, subtract y1, which here is -3, and then we're going to do x2, which is 6, minus x1, which is 2. I have a double negative situation, which means it becomes addition. So 4 plus 3 is 7. 6 minus 2 is 4. So we found a slope here of 7/4. Okay. You're going to try out this problem right here using that formula. Pause the video and resume when you're ready to check. Alright, I always take a second to label x1, y1, x2, y2. I usually still do that just to make sure I don't confuse myself. Right, I want y2 minus y1 over x2 minus x1. 2 minus 6 is -4. -4 minus 6 is -10. Uh-oh, double negatives will cancel out, and then can we reduce? Yes, we can. 4 and 10 are both divisible by 2. So our answer here is a slope of 2/5. If you got 4/10, not bad. Make sure that you get rid of those negatives, but try to reduce. Right? Always try to remember to reduce. Next couple of problems you see here. It says find the slope with the line, and then it gives you this equation. Well, we don't want it in that equation. We want it in that equation. Why? Because as I mentioned, this m term is your slope, right? We call slope m. So what you notice here is that it's whatever's attached to your x, right? That's your slope. So if I can get these equations to look like this with y isolated, whatever's attached to x is my slope. So first, I'm going to add, sorry, not add, that was a bad start, subtract 7x from both sides. That'll give me -3y equals -7x plus 28, and then we'll divide by -3. Now, I don't really care what this term is. It doesn't really matter that much for this problem, because what I'm interested in is slope, right? These negatives are going to cancel out, leaving me with 7/3x. That's not going to reduce. I don't really care what this number is. It's like -9.3 repeated or something. I don't really care. I care about the slope, right? 7/3. That is what they were asking for in this problem. So why don't you go ahead and try this one right here. Pause the video and resume it when you're ready to check. Alright. You should have started by adding 5x this time, because it was negative. We need to add it to both sides. So 4y equals 5x plus 24. Then you would have divided by 4. Again, if you do each term individually, it's a little bit easier to see. Right, 5/4x. This becomes a 6, but it doesn't really matter. What we care about is your slope, which here is 5/4. Now, I mentioned this a couple of seconds ago, right? Y equals mx plus b. I told you your m term is your slope. What is b, though? If you remember, it's your y-intercept, meaning the point on the y-axis, right, the vertical one, where it's going to cross. Okay. So we actually found. Remember the numbers I set up here that we don't really care that much for right now? Those are your y-intercepts. Now we probably want to know what they are, right? Knowing that this is a 6 is a good thing for when we want to start graphing these lines, right? But in terms of slope, we didn't need those, but now if we want to graph, now we need them, right? So it depends on what they're asking you for, if and when you need them. We're going to graph these two problems on the same graph here. So if you want to get yourself this is a 10 by 10. We're going to do one together, and then you're going to try out your own. You can graph them on the same plane if you'd like to. I'm going to do them in different colors to keep them separated. So let's try this first one out. First of all, we need to put it in the correct form. We'll have to subtract 9x from both sides to do that. So 6y equals negative 9x minus 18. Divide by 6 to every term. This will reduce to negative 3 over 2x, and this will reduce to minus 3. So now my y-intercept is down here at negative 3. My slope, rise over run, I always do either my up or down first, and I always attach that negative to the top number. So that tells me to go down 3. 1, 2, 3, and then I'm always going to go to the right after that. So negative 3 over 2, and that gives me the negative slope that I want. So I have to go down 3 again and then over 2. Now the other direction, I know I have to go up and backwards in order to keep that pattern the way that I want. So up and backwards, up, backwards, up, backwards. Right? And then we just connect all those together. You don't have to be as precise as this. I mean, you could do your best to draw a straight line. Okay. Probably wasn't even worth the time to use that little stick thing anyways. Okay, so there is your line that matches right here. You have a problem to try out right here. Pause the video and resume it when you're ready to check your answer. Okay, you should have started off this problem by subtracting 10x. So 4y equals negative 10x plus 16. We'll divide by 4. So that should give you, let's see, negative 5 over 2x plus 4. So your y-intercept here of 4. And then it tells you go down 5 and then to the right 2. So down 5, 1, 2, 3, 4, 5, and then over 2. Down 5 and then over 2. 2, 3, 4, 5, 1, 2, somewhere over here, and then again backwards. Maybe we go up 5 and backwards 2. So here's the line that you should have come up with. Again, draw it as straight of a line as you can. I know it was a little crooked there. Alright, we got a couple more for you to try. These are some pretty straightforward problems, but what you might notice here is that our slope looks different. Well, not a big deal, right? Because if you remember from our fractions lesson, all I have to do is put a 1 underneath, and now I've got myself a fraction. So it tells me to start my y-intercept at negative 3, and then my slope is 2 over 1 now, right? So up 2 over 1, up 2 over 1, up 2 over 1. Or I could go down 2, backwards 1 if I wanted on the other side. So you got one to try out right here. Pause the video and resume it when you're ready to check. Did you put a 1 underneath? Would have helped. Did you put your y-intercept up here at positive 4? And then finally, did you do down first, right? Down 3 and then 1. Down 3 and then 1. If you did all those things, then you got this line, which is the line that you wanted. I think that's it for that lesson. That's it, really. Graphing, line, slope, all that stuff, pretty easy to do. It's going to come in pretty handy throughout this year for a few different things. So practice it if you need to. And I'll see you at the next lesson. Bye.